Hello everyone, and welcome back to the AI Research Roundup. I am Alex. Today, from Papers with Code Trending Papers, we have Nexus-Gen, a unified model for image understanding, generation, and editing. Published around April 2025, this paper introduces a system aiming to unify these visual tasks. Nexus-Gen combines LLM reasoning with diffusion model synthesis, handling multimodal inputs, that's both text and images. A key is aligning their embedding spaces, how they represent data, through special training. They also improve autoregressive LLMs, which build outputs step by step, using a new prefilling method for better image generation. So to see all this in action, the authors have also shared the code for this work. Over on GitHub, in their Nexus-Gen repository, you can find things like the modeling and training scripts, specific files for image understanding, generation and editing, and even a Gradio demo, which is a simple interface to try it out yourself. Alright, and figure 1 here really gives us a great visual overview of these image generation and editing abilities of Nexus-Gen. We see several pairs of images. On the left, an initial image generated from a text prompt, and on the right, how Nexus-Gen edits that image based on further instructions. It's pretty impressive stuff, showing transformations like changing a cartoon to a realistic style, adding elements like a rainbow, or even shifting an entire scene to a different artistic style like anime or Ghibli. This really highlights its sophisticated editing power. Alright, so after seeing what Nexus-Gen can achieve in those earlier examples, figure 2 here, this diagram really lays out the architecture. An input image is processed by a vision encoder, creating input image embeddings, which are numerical representations. Text input is handled by a text tokenizer, becoming text tokens. Both feed into the central autoregressive transformer. This transformer then generates output image embeddings. Crucially, these live in a shared embedding space with the input embeddings. These are then turned into a new image by a powerful vision decoder. The transformer also outputs text tokens, which become the final text output via a text detokenizer. Okay, so building on that architecture, figure 3 here zooms in on a key challenge with autoregression. That's when the model generates outputs like image embeddings, which are numerical image descriptions, one token or piece of data at a time, using its own previous outputs. Part A shows naive autoregression, where training and test time differ. At test time, this use of its own outputs can lead to error accumulation. Small mistakes just build up. Part B then shows their fix, prefilled autoregression, which uses special image tokens consistently to unify behavior and prevent those errors. In this plot, figure 4 really drives home the point about error accumulation and naive autoregression that we just discussed. It's showing the mean squared error loss, which is a way to measure how different the model's generated image embeddings are from the ideal ones, with lower values being better. We can see 2 lines, the red line for training time and the blue line for test time, plotted against the token index. So that's as each piece of the image embedding is generated. Notice how the blue line, the test time error, is generally much higher and more erratic than the red training line. This difference really visualizes that error buildup. Okay, so after looking at how they address that error accumulation, figure 7 here really shifts focus to showcase the high-quality image generation capabilities of Nexus-Gen. We saw some generation mixed with editing earlier in figure 1, but these examples here are all about the raw power of creating images from text prompts. You can see a real variety of subjects and styles, from a photorealistic man and Batman to more whimsical images like a cartoon unicorn or a penguin in a hat, and even imaginative scenes like a nuclear explosion in a jar. This really highlights how well the model's autoregressive transformer understands language and how effectively the diffusion vision decoder then translates that understanding into detailed images. So while figure 7 really showed off that direct text-to-image generation, figure 8 here illustrates something even more sophisticated. It's multitask collaboration. First, the user gives a pretty simple prompt: a river, castle, waterfall, sunrise. Then Nexus-Gen uses its language capabilities to expand and polish this into a much richer, more descriptive paragraph. And then it generates the beautiful image you see based on its own enhanced description. This really shows how its understanding and generation abilities can work together to produce superior results from minimal input. Alright, so we've seen Nexus-Gen's ability to generate images from scratch and even enhance prompts. Figure 9 now shifts our focus specifically to its image editing capabilities, and it's quite versatile. We see a whole range of edits, from straightforward color changes like making an umbrella black, to changing artistic styles, for example, transforming an image to a Ghibli animation. It also handles adding or removing elements, like putting sunglasses on someone, and even complex multi-step instructions like changing a character's entire outfit, hair, accessories, and the background scene all at once. This really shows the model's precise control. As we've seen, from generating complex scenes to making those really nuanced edits we just discussed, Nexus-Gen truly showcases a powerful, unified approach to visual tasks. I think the big takeaway here is its ability to bring understanding, generation, and editing together so effectively in one model. And that's important because it really pushes us towards more versatile and intuitive AI creative partners. Alright, that's our AI Research Roundup for today. Thanks for joining me, I'm Alex, and I look forward to our next exploration.